Now, those skills of listening to people, they can be quite frustrating sometimes as well. So I think we're going to see an explosion, expansion of different roles and roles that we haven't thought of previously as well. Your customer focus, because you're leveraging metadata, increases with the size of the ecosystem. We have this idea there, like robots following a script. I would imagine it's actually quite different.
Hi, folks. I'm very happy to have Simon with me. Simon Wardley is the creator and/or discoverer of the idea of mapping strategy, and it's called Wardley Maps. I personally used Wardley Mapping across the last 5 or 7 years to great benefit. I've taught Wardley Mapping to hundreds of founders. And each of them has come back and said that it's helped them in many, many ways. So it's a pleasure to have Simon on here. The whole idea of Wardley Mapping came about because Simon met a CEO who had grown through the ranks, who was supposed to know strategy and was expected to deploy strategy, but found that he didn't know strategy. And so Simon talks about this person was thrust into this role and how that person learned strategy and figured out a tool to both look at strategy and to both use strategy. So it's a pleasure to have you here, Simon. Thank you for coming on.
First of all, it's a delight. Absolute delight to be here. Lovely to see you, Prasanna. I'm looking forward to this event. So quick correction. That CEO who didn't know what they were doing, who was making stuff up as they went along, was completely clueless. That was me.
Oh, is it?
So I was the CEO of the company, and I used to come up with these wonderful vision statements and other bits and pieces, which were total garbage. They were just words I'd copied from other people. I didn't realize what the problem was. I suspected it's because I hadn't done an MBA that I was missing something. And it was through a bunch of accidents and mostly involved with reading loads of strategy books, getting nowhere, being at a bookshop in Charing Cross. And I talked to the bookseller and she asked me, had I ever read Sun Tzu's The Art of War? And I had. So she sold me 2 different versions of the book because she was great as a bookseller. And I'm very, very grateful because in the reading of the second version, I noticed this particular pattern. And that pattern had a number of different factors, one of which was understand your landscape. And that's what started me thinking about how do I map a business landscape? And I sort of assumed at that point, that's the secret you learn when you go to business school. These days, I teach at a number of different business schools. They drag me for a day here, a day there to teach about mapping. But back then, so this is back in, 20 years ago, I thought this was the secret sauce you learned at business school. And because I hadn't done an MBA, it took me, probably about a year to develop a way of actually mapping the landscape. And I made it all Creative Commons because I thought there'd be other people in my position who might find it useful. And so that's where it all started from. So just the correction is, it wasn't somebody else who was the CEO, it was me. It was a small company. I mean, many millions in revenue. Staff was not huge. It was like 40, 50, something along those lines, in terms of, so not a big company, but we had like millions and millions of users online. It was a online photo service and about 16 other different lines of business as well. And mapping helped no end. So, but it all started with accidents. It all started with me not knowing what I was doing.
Awesome. So one of the things that I loved about your book, which I've read a few times now, is it begins with the story, right, of the CEO who doesn't know what he's doing, and
that was me.
It's mirror on the wall. Look at who has the strategy of them all, right? So that's fantastic. So Simon, when we look at evolution of tech, right, and we look at things changing,
Yeah.
We've seen many different evolutions, and Carlotto Perez talks about technological revolutions
Yeah.
and how at different stages of uh, this technological revolution, different things happen, both on the finance side, both on the startup side, and in terms of the tech itself being used, and so on and so forth. Right? You've also written about this, and you also thought about this a lot. Can you tell us, from an AI stand or machine intelligence, machine cognition, artificial intelligence standpoint, where do you think this revolution is? And how come it just in the end of 2022, nothing was there in AI before that day, and then suddenly so much is there in AI after that day? How does it happen?
Gosh, loads of things. Okay, so first of all, let's start by clearing up a couple of things. AI isn't one thing; it's a massive, great big field, of which large language models and large multimodal models, they're very noisy and very popular at the moment, is just a subset of that field. I'm not a big fan of the term artificial intelligence. It sort of implies it's like human intelligence but artificial. I used to, a long time ago, work in neuroscience. Back then, this was almost 30 years ago. In fact, it's over 30 years ago. We used to joke that we knew, 5% how the brain worked. I caught up with some friends who still work in that field, and I said how we've done in 30 years, and they said we're up to 3%. So we've learnt there's far more than we actually know during that time. So I prefer to talk about machine cognition, machine intelligence, machine learning, because it's not human-like. I mean, we talk about neural networks as though they're somehow mimicking the biological, and they're not. I mean, anyway, we'll talk about the field of machine cognition. So being new, yes, it started in the 1950s, 1960s, and has been progressing along. One of the things you find with evolution is evolution consists of multiple waves of diffusion. So if you think about the evolution of the mobile phone, you basically get the first appearance of phone. It spreads through a small, it becomes 100% adopted in its small applicable market, and you get a better phone, and the market always expands. But we see this product to product substitution. It feels like it's taking quite a long time, and then suddenly something will transition. That'll be the next form, the more industrialized form, and that feels like it suddenly comes from nowhere and takes over everything. But it's not the case. There's a long history. So the classic example of that would be something like computing. So if you think about computing, it first started the Z3, 1943, first digital computer, and then you got things like custom-built examples, Lions Electronic Office. And you got the first products, the IBM 650, constant diffusion, improvement of products, ever expanding, and we get all the way to pizza boxes and things like this. And then all of a sudden, 2006, after a first early start with Sun Cloud, but 2006 was really the kicker, we get EC2. And all of a sudden, it's starting to spread, it's starting to rapidly grow, but people have seen compute go through this product phase for, what are we talking, 40 years, 40, 50 years, and they think, it's going to take, 40, 50 years for this stuff. And it doesn't. It rapidly spreads. First 5 to 8 years, it seems to take over enormous amounts of things. Winners and losers emerge, and all that sort of stuff happens. And then by 10 to 15 years, it's like the new norm. And of course, then the laggards will take longer. So you're seeing exactly the same going on with large language models, industrializing components, causing, and it's the same effects. They cause explosion of higher order systems. So change of practices, what's known as a punctuated equilibrium, this feeling of rapid change, but because we've forgotten all about how long it took to get there. And this idea that you have choice, which you don't. It's not a question of if, it's only a question of when with these types of systems. And this is exactly the same as it was with cloud. It's the same as it was with, pretty much every one of these industries. They accelerate when communication mechanisms change, postage stamp, printing press, telephone, etc. Right now, is there a change of communication going on, which is accelerating the process? Possibly. Unfortunately, we don't get to learn that until post-event. Not normally when we're in the middle of it. And so if you go back to cloud, everybody was like, oh my God, everybody's going to be using cloud within 2, 3, 4, 5 years. It's going to be there's going to be no sysadmins and all the rest of it. Those of us who'd seen this stuff were like, oh no, it takes a bit longer. You get things like Jevons paradox, explosion of new higher order systems. So your estate goes from 2,000 physical servers to 200,000 virtual servers. So you'll find that all those sysadmins you fired, you had to hire back, but you called them DevOps engineers and you needed just as many. And so all the same myths, there's nothing to tell us so far that anything is really different with the previous cycles. It's the same. You don't have a choice. You'll have to adopt. Software engineering, software development will change. There'll be increasing use of AI in this space. A whole bunch of CXOs will fire all their software engineers because they've been sold a story they don't need them anymore, and then have the desperate scramble to get them back when they realize the amount of workload explodes through the roof. It's a punctuated equilibrium, so it's going to move faster than we realize and catch us out by surprise. There'll be a change of practice. We still haven't got the name for that. The same as DevOps with cloud or FinOps with serverless. That's all perfectly normal. You'll see an explosion of higher order systems and new things. All boring stuff, and I'm sure stuff we're going to talk about at your conference, because we're doing not only a keynote but also a workshop, and I'm sure we'll deep dive into some of this stuff there.
Absolutely. So Simon, one thing, given that you've been following this whole machine cognition, machine intelligence thing for a long time now, do you feel that some things are changing quite rapidly, right? And I'm sure that you see there are some very surprising things that are happening, right? Some folks who are who started off as very base layers, building the models themselves, and building the foundation models, saying that they're going to spend trillions of dollars building the models and stuff like that. Surprisingly, they seem to be getting into applications and build applications, and a lot of people are surprised by that. But are you surprised by that? And where do you see these kind of companies which were expected to stay in the background, stay as utilities for everybody else to make money, suddenly they're like coming and trying to chew up lunches, right? What do you think about that?
So when I created mapping back in 2005, so 20 years ago, there's a whole bunch of patterns which I demonstrated in terms of what we call climatic patterns, so the weather, how the landscape changes, and that's useful for anticipation, prediction of change. And then there's doctrine. These are principles. They're useful for organization, how you structure yourself. And there's gameplay, which are all context specific. There's about 30 climatic patterns, about 40 principles, about 150 forms of gameplay. One of those forms of gameplay is a particular game called ILC, Innovate, Leverage, Commoditize. And it's very simple. What you do is you take something which is late stage product, you turn it into a utility, expose it through an API or some protocol or some interface that other people can build on top, and you let people build new things on top of it. Now you have to build them because you're providing as a service, and your billing data, your metadata is extremely useful because let's take compute. Let's suppose we're in 2006. It's compute's very much a late product, and we decide to produce compute as a utility, and we'll give it a name. We'll call it random something, EC2. So we produce this, and then people build on top. We have to build them, and if a whole bunch of people produce kit and internet, Okay, we can see they're building an internet for kittens, and that's interesting, not going anywhere. And then a whole bunch of people produce big data services. We can see their bills are going up. So this tells us that something interesting is going on in that space. So we might look at that space and decide to come out with big data as a service. We'll give it a random name. We'll call it, I don't know, Elastic Map Reduce. And then what will happen is a whole bunch of people will cheer, because I've now got computers as a utility and big data, Elastic Map Reduce, big data as a utility, except for those who are business model was big data as a, they go, you've eaten my business model, terrible. Right, this particular model is very simple. You get everybody in the world to innovate for you. That's the innovate bit. So you don't do the innovation, you get everybody else to do it. Then you leverage the entire ecosystem to spot those growing patterns. So that's the metadata. And then basically the C bit, so you leverage the ecosystem, you get everybody else to innovate for you. And the C bit of ILC is you commoditize those to component services. So what you're constantly doing is focusing on the industrialization of components. Now, it's over on the shelf back there. There's a book called Reaching Cloud Velocity. It was written by AWS. They have 17 pages of my mapping in there. They have the ILC model in there. You could see Amazon AWS early on was playing this game. And the reason why this game is powerful, or they certainly seem to be mimicking this game, is that if you follow that model, then your rate of innovation increases with the size of the ecosystem, because everybody else is your free research and development. Your customer focus, because you're leveraging metadata, increases with the size of the ecosystem. And your efficiency, because it's economies of scale, increases with the size of the ecosystem. So innovation, customer focus, efficiency all simultaneously increase with the size of the ecosystem. And you can spot somebody doing this because people grumble, you're harvesting my business model. They're constantly coming out with more commodity services that pre-existed. They're rapidly seen as highly innovative, highly customer focused, highly efficient. So as soon as OpenAI launched, immediately people in the mapping community just went, they're going to play an ILC model because it's such bread and butter to us. You look at somebody like OpenAI, rapidly they're seen as highly innovative, highly customer focused, highly efficient. They constantly bring out more industrialized services, and people grumble, oh, you've eaten my business model. They're almost certainly playing an ILC-like game, moving up the stack on the right-hand side of the map, constantly mining metadata, which includes prompts to identify new patterns which they should launch. So is it surprising? That's common sense.
Yeah, so I think one of the interesting things is that every time this is happening, whether earlier with an Oracle or a Amazon or a now with an OpenAI, right? There are so many cries of hey, they're killing startups and they're taking away.
I'm not sure you'd put Oracle in the same list as AWS and OpenAI. Part of the problem with sort of things like Oracle and many of those services is they have an ecosystem built on top, but that ecosystem that is built on top is all about customization of the actual platform itself. And so they tend to want to support that ecosystem. They're not really focused on industrializing. If they were focused on the end users, because the end consumers want you to industrialize the hell out of stuff so they can get on to building more and more interesting stuff. But if you've got a consultant ecosystem built on top of your product, they're all like, oh, don't know, I get paid money for changing the same screen into, I don't know, cornflower blue or into yellow for different people. So I get paid loads of money for these configuration and pressing this button or whatever. So I don't think Oracle plays the game. I don't think it plays the IRC game. It plays the we are supporting our consulting ecosystem game. So this tends to mean you tend to move slower. They will industrialize some bits, but it's stodgier movement. It's slower. People feel more sort of captured in that environment. That's where I see them, and not just Oracle. Loads of people in that space. Whereas Amazon and I think OpenAI is doing the massive industrialized. They don't mind industrializing spaces. They don't mind chewing up their ecosystem as long as it makes end users more happy. That more of them are happy because they can build things more quickly.
Absolutely. Absolutely. So, Simon, one thing that a lot of people are talking about, and which is happening to some degree, is that in especially from a customer service perspective, many of the B2C kind of spaces where they have large call centers, they have lots of people talking to customers, both inbound support calls or outbound calls to sales and things like that, right? These spaces, obviously, they employ a large number of people in India, both from India calling to India and from India calling to the US or UK, or receiving calls for doing support from the US or UK and things like that. Right? And one of the things that seems to be happening is that this space with AI, with LLMs, with the voice models that have come up, is also looks like it's rapidly industrializing, and a lot of enterprises are looking at replacing people in these call centers with bots that can speak and complete these conversations and give results and things like that, right? And people are looking let go of large number of their BPO workforce, call center workforce, replace them with these AI, right? How would you classify that, or how would you think of that from a mapping perspective? Do you think any part of that workforce will survive this transition? What do you think will change when this happens?
Okay, so that's an interesting question. So we're two competitors. Okay, we've got equivalent sized companies, and we've both got large call centers. And we both decided to invest, because we all have to, in using large language models and using AI chat, etc. And so we've both decided that, we can reduce. We might need a few people around, but we can basically reduce the amount of physical people that we have in our call centers. We can automate, reduce the size of it. Okay. Now, the question then becomes: I'm one. I say, well, I'm going to fire all these people. Then I can just get rid of this headcount. Isn't this great? Okay. Let's say you take a different position. Let's say you decide that you're going to reduce, or you're going to automate and industrialize this stuff. But rather than firing the people, you're now going to redirect their effort into something else using those AI services. So, because I don't work in the call center and the experience stuff, you'd have to find somebody who does, but they should be able to pick up. They might go, well, we can actually, there's a long list of things we've always wanted to do, create much more experiential services. So we could get those people working on that using vibe coding environments, creating a plethora of different prototypes in that space, test and create greater experiences for the end users. Again, as I say, I'm not an expert in call centers or experience or whatever, but if you find somebody in that space, they might be able to go, well, actually, we could take these people. There's a whole bunch of other things that we could do to create a much more experiential service than just chat with a robot. Well, if you go and do that, and assuming it's successful, then I'm going to have a problem because I'm competing with you. And now you're throwing out all these new services. I've got rid of all my capability to do those sorts of things. Now, so in some cases, yes, we can get rid of these people. As we industrialize stuff, we reduce it. But we have to be very, very careful. Don't rush to do this. You want to look at the space, because if you're in competition with somebody else and somebody else is a bit more finds that they can improve the experience somehow, or they can use software engineers to review code so they can expand their capability of building things by getting engineers not to write code but review code or something along those lines. You might find yourself at a disadvantage because you've just now got rid of that capability in order to save a little bit of money. And yes, it looks good in terms of the balance sheet and helps my bonus and all the rest of it, but it is not necessarily the right long-term play. So I wouldn't rush into those decisions of getting rid of people. Absolutely automate stuff, but I would also spend some time thinking, is there places we can reuse those capabilities? If not, fair enough, but I wouldn't just assume. Does that make sense?
Absolutely, Simon. So I think,
have you got much experience in the experiential type space at all? Was there something you could think of the top of your head?
I see some challenges as well, not just in terms of, one is of course in terms of doing more for the customers.
Yeah.
On the other side, the challenge is that in many of these call centers or BPOs, the type of people that are being hired, will it be possible to upskill them to get them to do more? Becomes a question.
That's a perfectly valid question.
Yeah, and then the ratios in some of these places are just 3,000 people working in the core of the business, and then 20,000 people in the call center and things like that. So what ratio will work to be able to absorb people becomes a question, right? And then
so what are the main skills of people within call centers? I mean, the main skill is listening to people.
Yes.
Okay. So there's I would imagine there's a large emotional quotient type capability, because they have to listen to people, they have to deal with people whose emotions can often be they're in fraught situations, they have to deal with that kind of this sort of listening to end users, listening to customers, listening to what they need, trying to help steer them down a path and all the rest of it. I mean, because in some respects we imagine that they just follow a script, and I'm sure there are paths, but I've never worked in a call center. We have this idea they're like robots following a script. I would imagine it's actually quite different from that.
Absolutely.
Now, those skills of listening to people, that emotional quotient, that being able to attune with a person, those are quite rare skills, quite valuable in other areas as well. So I imagine it wouldn't take a great deal to think about how I could redeploy those into other spaces of the organization, because certainly your AI chat can do that. I can read a script at you. And they can be quite frustrating sometimes as well, particularly when you realize, maybe you need some voice systems listening in at the frustration of the end consumer's voice when they start swearing at the damn robot and getting really angry, at which point you have to have a human intervene or something along those lines. So you can deal with a vast more people, but you become more attuned to the whole sort of emotional quotient side. I imagine there's all sorts of possibilities.
Absolutely. Which then leads to the next question, right? So one is, orgs need to be able to figure out how to absorb a proportion of people which they may struggle with. And the other side of it is, maybe I need to be able to sell more, right, as well, of my services or whatever I'm delivering in order to be able to deploy these people into more roles or increase my top line in some way, shape or form, right? And again, that may be a struggle unless they figure out both what I need to sell more of and have the capability to sell more of it. Right? What do you think about that argument?
So back in 2018, I did a talk at Serverless Conference about how we were going to get a shift of machine cognition, combining with some of the practices we're seeing in FinOps, to create something called conversational programming. So this environment, so it's based upon the ideas of Nicholas Negroponte and Jonna Freeman, that design is a conversation between the perspectives of multiple designers. And what will change is one of the designers will be the system itself, the machine. And so this was conversational programming. Alexander went and built this at AWS reInvent 2018. So they had an AI system which you could have a conversation with, and it built you a deterministic code-based system. So it coded you another system. And of course, you roll forward to 2023, and now we've got, chops, we've got prompt engineering, we've got vibe coding. These are all flavors and forms of conversational programming. So we knew this stuff was happening. Now, back in 2013, I wrote an earlier post. We go all the way back to 2008, but we won't, not now. So 2013, I wrote an earlier post upon near and crazy ideas. And so you could see back in 2013 that we're increasingly getting to a world where we're going to see intelligent agents, which is the words I used back in 2013. They actually come back from earlier. But what's interesting is you can then start to see the jobs that will disappear. But what becomes difficult to see is the jobs and the types of roles that will appear. So I gave a few examples, one of which was machine psychologist. Which I'd like to be.
I love that one.
So we're going to have these wonderful sort of like increasingly emulating biological sort of efforts at machine intelligence. Of course, it's going to get its own neuroses. Of course, it's going to get its own errors and faults and other bits and pieces. We'll call it in different terms. And we're going to need people who can actually have a conversation with it and try to get to understand. Because often its output is non-deterministic. It's the model. The conversation is non-deterministic. So we're going to have to develop the techniques of observation, how we get into the system, understand what's going on with the system, potentially understand the faults with the system. So I think there's going to be a vast array of new jobs, a bit like, when Jeremiah Hawkins wrote New Catechisms of Electricity, which was back in 1896. It was basically electricity was going to make everybody unemployed. We're going to have machines, electricity, everybody's going to be unemployed. Isn't it terrible? And then you could say, well, you could be a radio operator. And someone would go, what's a radio? So we couldn't see, or television operator, I should say. So we couldn't see the roles coming towards us. Or it's the same with Cybernation, the Silent Conquest, which again was another one of these wonderful books. That was Donald Michaels, and that was back in I think 1970, just at the very beginning, maybe 1960s. And it was again how computers was going to make everybody unemployed and all this sort of stuff as well. And of course you could go, but you could be a social media consultant. People would go, what's social media? So I think we're going to see an expansion of different roles, and roles that we haven't thought of previously as well. So I'm still hoping to be my machine psychologist. There we are. Now, of course, the game changes again if we finally get to AGI, but that seems like it's going to be the thing about AGI. So I did talk about this in 2008. This was in San Francisco at I think it was Ignite 2008, and the point about this is, do I think we'll get to AGI, or so this is artificial general intelligence, or like a human? I think we'll eventually get there, but I think there's a lot of hubris in the fact that we think we will create it. I think it's far more likely to occur between the networks, between agents, and relatively large numbers of relatively dumb agents communicating with each other. The AGI will appear in the interfaces between all of that. And I think our biggest problem is we won't recognize it. We won't even know how to talk to it. It may well be a non-deterministic language, very alien to any language that we've ever seen before. So we won't recognize it for ages. We won't know how to communicate with it. I mean, we've got a lot of hubris that we will build it. I think it's much more likely to spontaneously or accidentally occur. Anyway, that's another story. Did I answer your question? I did.
Absolutely.
I just chinwagged for too long. There we are.
No, that's part of the fun of speaking with you, Simon. So, on that point, the paradigm for companies to use AI has gone from, hey, I was doing machine learning on a few things with bits and pieces of data to, hey, let's give everybody a chatbot that interface to an LLM to, hey, there'll be a co-pilot which is, look over your shoulder and, helping you do stuff, reminding older people of Clippy and some PTSD there. Now people saying, hey, no, you don't need the AI to be waiting on people to, help people.
Okay.
Let's get agents which, go out, do stuff by themselves. All you need is to give them a little bit of reasoning and give them access to every tool and every piece of data in your organization, and they will just magically do the right.
Magically do it all. Yeah. Okay. We have these mass delusions. Yes.
And you can just let go of all your people. Everybody will be commanding armies of agents.
Yeah, this is very cloud. Okay, yes. So as in a whole bunch of people got rid of all their sysadmins and then had to scramble to hire them back as vastly more expensive DevOps engineers. But of course, in a market where everybody was after these people, the savvy ones had been hiring them off the company's firing. So there is some interesting changes. One of them is the first of all, these models are not very efficient. And engineering is all about optimization efficiency. Basically, once you built around a space, you engineer. Unfortunately, most of our software development is not engineering. So to explain that, there are two parts to software development. There's the testing bit, and then there's the coding bit. Now, testing uses highly contextual tools. Each test is a tool, input outputs. And so what we do is nobody turns up with here's 100,000 Acme tool test suite. You should use it on your application, because people will go, that's got nothing to do with my application. We build our tools, our tests, for our context. Now, this results in a number of very, fairly straightforward behaviors. One, test-driven development, which is basically we start with a hypothesis, which is, I think my application doesn't have this feature. So I write a test, and sure enough, when I run it, my application doesn't have this feature, it fails. Now I write the code to pass that feature. So our assessment is hypothesis-based. Our exploration of the space is with tests, small tests. So it's very, very systematic form of exploration. And our conversation is with the model. We often talk about the best specification for a system is the test suite. Well, yes, because it defines the model of what we've got. Now, the test suite, the tests themselves are basically they're generated, as in little traffic lights, it passes or not, and that's systematic code. That's system-specific coding. They are coded to a system. Okay, and the development experience is large numbers of small tests. That's what we do. We create our test suite out of all these tiny little tests. Okay. Now, when you look at coding, when we do the coding bit, we don't create our tools for our environment. In most engineering subjects you would. So if I think at home I'm making soup, I use a kitchen blender. That's a tool. But if I'm doing a deep mine shaft, I'm not going to use a kitchen blender. I'm going to use some mining tools. Okay. If somebody came up to me and said, oh, you're really rubbish at building deep mine shafts with kitchen blenders, you should use our robots with your kitchen blender. That's like, you should use an AI with your software development tool. Because what we're doing in software development, in the coding, is using the same tools everywhere. So if I'm building online gambling site or electronic healthcare record system, I'm using the same development tools. None of them are contextual. It's like I'm using a kitchen blender everywhere, and somebody's come along and said, "Oh, AIs with your kitchen blender or robots with you. That's good for deep shot." I mean, it's nonsense. But unfortunately, this is what we do. So we use standardized tools. They're not. We use manual inspection, lots of reading of code, rather than any specific coding. So it's manual inspection. Then we get into most of the conversation, most of the exploration. It's all ad hoc. It's all belief based, and then ultimately it's gut filled decisions, often on experience. So we get to a point, I think this piece of code will fix the test that we have. And then we run it, it doesn't work, or it does work. So what we have is this bizarre world in software development where we have testing as an engineering subject. But coding is a craft. It's not an engineering subject. And the reason why it's not is because we've become totally embedded with this idea of building tools is hard, and we need very, very, we try to use very specific, not specific, very generic tools like kitchen blenders everywhere, which is great for kitchen blender salespeople or for tools salespeople, as in all the big tool vendors. They love it. It's terrible for coding. So one of the interesting things about AI could be in helping us generate much more contextual tools. So composing lots of small tools, a bit like tests, lots of small tests, which we then basically combine them together to create our development experience. So AI might actually help us turn coding into a much more engineering subject, which is the positive. But even without AI, the performance improvements I've seen from people using building small micro tools and building contextual tools out of this has been many orders of magnitude, 100-fold, 200-fold. So I hear people say, "Oh, our coding's so much better with AI, we can get a 5-fold or 10-fold." I mean, that's peanuts. Our problems is that the coding aspect of software development is not an engineering, it's a craft, and that needs to be improved and optimized and changed. And AI can actually help us in that, but just doing that alone has enormous benefits. And so when you think about systems that we build, I mean, ideally you use engineering to optimize something. Well, we're not. Our coding is not engineering; it's a craft. So we haven't been optimizing a lot of this stuff. And so AI looks like, but AI is really, really expensive for what it does. So as we get better at this over time, as we turn coding into more of an engineering discipline, which is what I suspect will happen, we may discover that actually AI isn't suitable everywhere. It's just not efficient.
Awesome.
But we're not in that position at the moment.
So this evolution of coding from craft to engineering, how would you see that from a mapping perspective, and how long do you think that's going to take?
Well, I map that space out. You've got a huge, we'll talk about issues of inertia in one of the workshops that we're doing. You've got multi-billion-dollar tool vending industry who has no interest in you learning that building tools is actually really easy. That you can actually combine multiple micro tools to create a context specific tool for your environment, and that's what we should be doing. Now, they have no interest in that. They want you to buy their tool. It's a bit like, I don't know if you remember before test driven development and the idea of using small tests. I mean when we first started doing this stuff, this is back in the 2000s, very early 2000s. The idea of doing test-driven development, writing tests before you write the code, just was like, it was alien to people. It was like, Oh, well, why would you do that? You write the code and you hand it off to these other people who go and test it. Why would you start with writing the test first? And why would you automate this and put this in code and make these small? It was like there was huge resistance against it. But over time, people realized, this was the right way of doing things. We should be doing exactly the same with all our tools, as I say, tester tools. So we should be, building our tools for the problem. I've got an example for a particular company. It was a $16 billion market cap company in the US, had a problem, a legacy system written in dead language, as in the developers were dead, the people who wrote the language were dead, it wasn't maintained, anybody knew this stuff, it was all dead, okay? And this was right in the heart of their $16 billion market cap company, and they were terrified. And they'd had many multi-year efforts to try and get off this thing. And they just failed. Large teams, they'd spent like 20-person years, failed. And so they asked the people at Fenk, and Fenk is one of the groups I work with, to come along and look at it. And they give them all the code. About 4 weeks later, they had this meeting with Fenk, and the CIO internally for this company had made a bet that they will fail after a year. And so they said, "How are you doing?" And they said, "We're finished." And they were like, "What?" "We're finished." And the way that Fenk did it was they spent 3 weeks building the tool to solve the problem and 1 week solving the problem. And that's what makes the difference. And I mean, it is transformative. You suddenly go from, we spend, because otherwise what people do is they get 30 million line code system. Sometimes these are monsters, 100 million, but 30 million. They try and read the code because they've got a tool, and what that tool is, that here we've got our standard development tool, and it's good for reading code. So we go and try and read 30 million lines of code to try and understand. It's madness. The way we do the coding side is craft. There's awful lot of efficiencies, awful lot of changes needed. But unfortunately, our big problem is all the money is in the tool vendors, and they are not going to like it changing. So there's going to be huge amounts of inertia. And of course, it's all the tool vendors who are coming at you saying, use our tool plus AI. It's like kitchen blender plus AI or plus robot. It's great for building deep mine shafts. And I'm going, surely we want to use mining equipment? No, kitchen blender plus robot. That's the nonsense that we've got.
Parallel blenders.
Huh?
Parallel blenders.
Parallel, yeah, a whole bunch of robots with blenders. Just as, I'm saying, well, surely we want to build a boring machine, but there we are.
Awesome.
We're going to have some interesting debates going forward in that whole sort of AI space. It's going to expose things even more.
I will ask you one last question. The question is, what do you think is your most controversial opinion on AI?
Oh, what is my most controversial? Right. Well, it's not that the architecture. One of the key things about architecture, or key ideas going forward with architecture, is it really about where humans, where you value humans in the decision-making process. That's an interesting idea. I mean, the software engineering development or the coding practices is changing because of AI, because it's not an engineering subject. That's an interesting idea. The shift to non-deterministic languages. So at the moment, the output from many of these systems is deterministic code, which we can review. As we go forward, that's going to change, be more non-deterministic. So it's going to be models themselves. So observability is going to be much more difficult. Those are all really interesting ideas, and we can get into Jevons and so forth. But I suppose the biggest one will be in the sovereignty issue and the embedding of values within these models. So I did a piece of work back on this in 2015. I'll bring those maps there from the DVLA, where we identified that the simulation models are what we call training data. is where values can be embedded within these systems. So this was 10 years ago, and which is why we need the training data to be open as well. It's not enough for just the models and the algorithms to be open source. The training data needs to be open as well. And I think China's making really good moves in that direction. I don't think the West is. So that's probably my most controversial is the necessity for opening up the training data. It really needs to be all Creative Commons open source. It should all be exposed, and that China's going to lead the charge on that. The West, for various reasons, is probably not.
So you're saying that intelligence with the wrong values is dangerous?
It can be, yeah.
A little bit.
A little bit.
Awesome.
Very.
Awesome. That was a fantastic conversation as usual, Simon. I thoroughly enjoyed it. AI is changing the world. Did you enjoy this episode? Subscribe so you don't miss the next one. We are on all the popular podcasting platforms. Leave us a comment with your questions and thoughts. I'd love to hear from you so we can go through this exciting journey together.